This is one of 3 podcasts that will address insulin resistance and explain the biochemical changes underlying the development of insulin resistance. In order to adequately explain insulin resistance, one must recall some of the key tissue effects of insulin when it is released. Insulin produced in the well-fed state will have remarkable effects on at least 3 important tissues affecting their respective metabolism. Insulin exerting these effects on the various tissues will act by binding to its receptor and will initiate 2 types of effects: stimulatory effects and inhibitory effects. Starting with the liver, insulin will stimulate glycogenesis or glycogen synthesis and glycolysis. These 2 glucose-consuming pathways will use up nearly 60% of all the glucose present in the bloodstream after a meal. Importantly, insulin through its receptor will also have 2 inhibitory effects in the liver. Through a cascade of intracellular events, insulin will inhibit glycogenolysis or glycogen breakdown and will inhibit de novo glucose synthesis or gluconeogenesis, thus reducing the liver's output of glucose. Insulin will have some profound effects on 2 other tissues, muscle and adipose tissue. By specifically increasing the number of glucose transporters, GLUT4, on the surface of these 2 tissues, muscle and adipose tissue will pick up glucose from the bloodstream in an insulin-dependent manner. These 2 tissues constitute a significant portion of body mass, and as such, they can contribute to a significant amount of uptake of glucose from the bloodstream, reducing the amount of glucose in the bloodstream. In addition to these effects on glucose uptake, insulin will have specific effects on muscle metabolism. It will stimulate glycogen synthesis as it does in the liver, and it will inhibit glycogenolysis as it does in the liver, specifically in the muscle. There are 2 other noteworthy effects of insulin. The first one is that insulin will upregulate or increase the amount of lipoprotein lipase associated with the endothelium. And 2, insulin will inhibit hormone-sensitive lipase present in adipose tissue. The insulin effects on these 2 lipases will play a significant role in the development of dyslipidemia associated with insulin resistance. Having covered some of the key effects of insulin on various tissues, the simplest definition of insulin resistance is that these target tissues that insulin normally exerts its effects on become less responsive as a result of insulin resistance. That simply means that the tissue responses become less robust in response to insulin stimulating its receptors, be it a stimulatory response or an inhibitory response. Those responses are decreased or diminished because of insulin resistance. For example, insulin resistance in the liver would result in decreased glycogen synthesis or less stimulation of glycogen synthesis and less inhibition of glycogenolysis, meaning resulting in more glucose output from glycogen degradation. Insulin resistance, therefore, is more likely to represent post-insulin receptor effects. Changes in these post-receptor effects are more likely to be responsible for the decreased cellular responses in the various tissues. Insulin resistance is not a reflection of a decrease in insulin output by the pancreas. It is not, and it is not representative of a lower amount of insulin in the bloodstream. In fact, insulin output by the pancreas is frequently increased in insulin-resistant individuals. This is most likely to compensate for the decreased response of insulin on its receptor in target tissues. Although the exact details of how insulin resistance develops are not understood, there are at least 3 important features of insulin resistance to keep in mind. The first one is that insulin resistance may take several decades, 2 or 3 decades, before it develops and before its effects lead to the metabolic changes that are evident in the bloodstream. These changes are typically hyperglycemia and dyslipidemia. The second important feature about insulin resistance is that there is a strong correlation between developing insulin resistance and being overweight or obese. This simply means that there is an increased probability of developing insulin resistance with increased weight gain. In fact, weight loss can result in decreased insulin resistance and therefore restore some of the normal insulin effects on its target tissues. The third important feature of insulin resistance is that it implicates a role for adipose tissue in the development of insulin resistance. There is significant evidence indicating that the output of specific hormones and specific inflammatory molecules from adipose tissue may play an important role in the eventual development of insulin resistance.